Yeah, time for another draft physics and draft and debatephysics.com now. Video presentation. Yeah, I have to remember all this stuff. Anyway, Franklin Hu has generously, I think, apparently paid attention to one of my videos and responded to the simulation, and I do appreciate the feedback. Problem, it's in a form of a 15-minute video where he kind of just rifles off a lot of questions or points, and each one is a subject in itself. Why doesn't it obey Newtonian mechanics? Well, no, that's a subject. It's going to take me more than 5 minutes probably to explain why it doesn't have to obey Newtonian mechanics, why atoms aren't the same as baseballs, because they're not the same. Yeah, that's why. But anyway, so we will go through this, and so I'm sorry, it's going to have to be a long video. I don't know if Franklin's interested in listening to those explanations, but it's the way it is. I mean, his Sunday morning show used to be 2 hours long or whatever, Saturday morning. So you have to put up with it if you're sort of inviting it. So I'll start with the description. Draftscience has presented a simulation of how opposite charges affect. Okay, attract. Attract. Obviously, it's attract and repel, and it's really just my pursuit. Was in beginning this whole process, the whole channel started with gravity, and then as I recognized that gravity must be particulate, it's the only rational explanation. Now I had charge to figure out, why is charge so different? Why does charge do attraction and repulsion? And how can I make a simple little particle field create the charge effects? How can electrons and protons see this difference? What's making the difference? What in the field is different? And so anyway, and I just came upon the idea that, well, if I just make plus and minus forces to go with the plus and minus particles, that is, particles with round pegs and square holes kind of thing. I mean, the square pegs won't go in the round holes, the round pegs won't go in the square holes, blah, blah, blah. Inverse relationship, it creates attraction and repulsion. So I can use a simple idea of force. I just have to make sure the force is also inverse. That is, there's an electron field and a proton field if you want to use that. You could even think of them as being planes in universes, and you just combine the two universes, the proton universe and the electron universe. You combine them, and they're just a little bit out of phase, a little bit out of alignment, like 3D glasses. The purple and the blue is separated. Without the glasses, it looks wrong. And the same, so lots of explanations. But anyway, so my ambition was just to explain Maxwell's drawings. So Maxwell has a simple drawing. I'll get to that. I mean, it's just this idea. This is what charge is doing. It's this radial thing coming out of charges. That's how Maxwell drew it. The lines of force, not the field lines. The field lines happen when you combine two of these things, okay, and then you just start measuring the length of the line. The further away, the longer the line, the weaker the force from the positive or the negative. And if you want to know how something will move, you just measure the lines, how attractive it is and how repulsive it is. You just measure how long the lines are. It tells you how much force is being applied and what the path will be. And so the path is what the field lines are. That's the path. That's not the force. The force is doing this straight line thing. That's Maxwell's drawings. So I'm just saying that's what I was looking for. Some way to make positive things radiate like a sun, their positiveness, and negative things radiate like a sun, their negative, using the same field. I fell upon it at this simple answer. Two just simple, different answers. Round peg hits square hole, okay, and it turns, it's deflected. Round peg hits round hole, it goes in, it moves the object for a while, and then it's reflected eventually when a counter force hits it. So, but you really have to pay attention to those details. So he's arguing as if I don't have details. Yeah, I do have details, but I don't think they're terribly relevant. I think the only relevant detail is that I have taken something insanely simple to explain the elemental function that is the basis for all electrodynamics. And that's, as I would argue, a substantial step forward. But whatever. He's not wrong. It's sort of a left-handed compliment, but okay. But this is my response as to why it is incomplete. Now, compared to what? Compared to what theory is it incomplete? Maxwell's drawings were incomplete. He had no explanation for any of it. He just knew this is what it does. I'm giving you an explanation for why it does what it does. So it's hardly incomplete by comparison. And how it can be physically realized as waves in a neutron sea. Well, that I will totally disagree with. It can't be realized. They're not waves, frankly. I mean, I think there's already a tremendous evidence indicating it's rays of force. It's not waves of force. Nothing spreading as it goes out. None of that crap is happening. Photons land in very tiny locations. There's no waves involved. Anyway, so, I mean, I could rifle off a bunch of critiques of wave theory, that it has no sound foundation. The Young experiment's a complete canard and pile of crap. It actually doesn't work mathematically. I mean, I can go through all that crap, but I already have. So, play the video, Gary.
Hello, everyone. My name is Franklin Hu, and today I'm going to do a reaction video to what Draftscience just published today, which was an interesting simulation of his 2 + 2 + 2 physics, is what he called it.
Yeah, so it's been worked on for years. Okay, it's just so it's the idea already existed for years, and it's just now that we have a simulation that works because we have exactly the right simple. I mean, it got simpler is the funny part, and so a simple fixes things that made it simpler, made it work better. And it will eventually, form atoms, and then it will show gravity, and it will make magnetism, and it will do charge, and it will do all of it. Because it has all the elements you need. Charge is really the universe. Gravity is just a symptom of what charge is doing. And then everything else is just obviously an extension of charge. Magnetism is just an extension of charge. That's why it looks so much. North-south looks so much like plus minus. Because it's just the same thing, manifest as a pattern. And photons are likewise the same thing, just manifested as frequencies.
But what it's really showing is why in the world would, say, a proton attract an electron, which is a very fundamental problem.
Right, so I have gone over this, hundreds of times in my videos. The drawings are on the website, about the arrows going in. Red arrow goes in, it comes out blue, blah, 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 blah. The change in color thing is a new thing, so that might not be in some of the old drawings. So, because in the old days it just was the same color turn. So a blue arrow goes into an electron. The blue arrow would turn, that would be the right-hand rule, and it stayed blue. And the key to the whole thing was just realizing that what really happens is it turns red. Now, what that really means is inside the electron there can be a lot of force bouncing around, and what's really happening is there's an exchange. A blue thing goes in, it hits a red thing going this way, the red thing keeps going, and the blue thing stays inside. That kind of argument. But I don't think those speculations as to mechanism are nearly as important as having a simple mechanism that you can use for everything to explain why it exists. So it explains gravity, magnetism, charge. It explains everything with the same mechanism. That's profoundly, game-changing.
And most people just eventually, just say, well, plus attracts negative, because plus attracts negative. That really doesn't solve things. So, I would congratulate.
Yes, just as bent space is not an answer in the sense that, what do you mean? What does an electron see when it sees bent space? What is it feeling? What's the thing? How does it know it's supposed to go some direction? What's the river made out of?
Science, actually coming up with, I would say, at least a plausible, reasonable way of explaining, why electrons should attract protons.
Well, again, I came up with that 8 years ago, so again, no one was interested, and that's just a sad fact. So as a diagram, I had already drawn a basic mechanism explaining how you could have this very simple way of having an inverse relationship between electrons and protons, so that they could be using the same field and get these very different reactions out of that same field by merely having these two qualities, and these two qualities are inverse in terms of how they affect each other. Square peg, round hole. It's that simple.
And he actually built a simulation out of Blender. So if you haven't...
Yeah, it's not really Blender, it's HTML, and the guy who built it, yeah, I'll wait until he wishes to be famous. But yeah, he did a great job. I mean, another guy, probably can say in Australia, also was incredibly helpful working on simulations. So there was two people who were it was just great to be able to, for them to turn what I was saying into some kind of mechanical thing, even if it wasn't perfect, because it just made it clear that, oh, that idea won't work because, yeah, it's all turns into zeros, nothing happens. So it was incredibly useful in the process of trying to find the right answer. To have even a broken simulation was better than no simulation, and it was really useful. And so, a lot of credit has to go to their feedback and their interaction with me in trying to design the simulation. Designing the simulation was more valuable than I think the actual product is.
Seen that, I'll see if I can link that below so you can see the original video. But the strange thing he does...
So eventually it'll just be a web page. You can just open it on a web browser and it'll go and do its thing, and you'll be able to adjust things and change the universe any way you want, all that kind of crap. But we're going to wait till it's done, where most of the important features are in it, okay, before it's released as a toy. Yeah. But it's really cool, frankly. You can, it's really interesting to play with it. What happens when I throw 10 things in? What happens if I have 3 electrons over there and 6 over, what happens? It shows you a lot of what happens stuff, and it's really interesting.
Doesn't really explain exactly what's going on with the simulation here. So
I have explained that in these videos I've done over and over and over again, millions of times, and blah, blah, blah. And yes, some of them you have to pick and choose. I have some basic videos on the basic subjects that do explain the charge, gravity, and photons. And I have them linked, and they're on the website, blah, 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 blah.
I'm going to try and show that with this one little chart here. And what he has is that he has a big red dot, big red dot, and a big blue dot. And what you can see is that what's happening in the blue dots is that tiny little blue dots.
So I guess I should show this simulation here, right? And that way I can draw it. It duplicates Maxwell. So what really happens is there's a field of red and blue randomly flying around as the universe creates it. Everything's in that field. We're in a field of it that probably has directions. There's some built-in directions. But anyway, it doesn't really matter. And built-in biases. Everything's drifting in a direction based on that field. But anyway, it doesn't matter. And electrons and protons are sitting in that universe. That's the real universe. The real universe is that field of little stuff moving the speed of light, little pieces of momentum. And their electrons and protons have a difference where they can see the difference between the red bits and the blue bits, and they react opposite to the two kinds of matter. And so what actually happens is there's red and blue in the field, but because of those two interactions, the red objects only radiate red. So no matter if blue comes in, it comes out red. Red goes in, it comes out red. So they're at thermal equilibrium. The same amount goes in, comes out eventually. Because when they're moving, not the same amount's coming out. But anyway, that's another point. That's how gravity is created. So you end up with objects that are just like Maxwell's drawings. You end up with objects that are, one's radiating blue, negative energy, the other one's radiating red, positive energy. And the red energy will repel protons, and the blue energy will repel electrons. And so that's a better way to visualize it, is it turns the red and the blue objects into red and blue suns, you could think of it as. And magnets can see the red and blue. Different things can see the difference in the colors.
Are flying out of here, and what's flying out of the red dot are other tiny little red dots.
Right, so it's not flying out, it's what came in and reflected in all cases, in the sense that even an absorption and a deflection is a reflection. Everything that goes in eventually comes out. So it's all going in and less comes out. The very same thing that's creating gravity, in my opinion, is more energy goes in to the Earth than comes back out, because the energy is moving electrons and protons in the Earth, and moving them means they're not going the speed of light anymore, means you have taken a little bit of their energy.
So this is part of his...
So more goes in than comes out, which means you go down. So the fact that it unifies physics, it explains gravity, connects gravity directly to charge, is again another very important feature. The simulation will eventually simulate gravity. When a group of those things stick together, I'm going to be able to just demonstrate that more energy went in than went back out. That the time that force bits were involved occupied will increase, and through that occupation less will be coming out than went in. And I'll show you gravity.
2 plus 2 plus 2 explanation, in that he says that there are, for example, two kinds of matter. So like you have the positive matter and then you have the negative matter.
Electrons and protons, and a neutron is an electron and a proton. Very close together. There's just electrons and protons. There's no positrons, there's no neutrinos, there's no any of the other things they talk about. They don't exist. There's no quarks, there's no smarks, there's no gluons, there's no puons. There's just these two.
And then he says you have two force bits, and they are similarly colored. So we have these little blue force bits, and there's an arrow showing the directions. And so the matter bits are spitting out these force bits of the thing. And then there are just two interactions, so that if like the blue bit hits the red bit, it is simply absorbed.
All right, so this is the part where, yeah, you have to spend some time recognizing finding the videos or watching the videos where I explain, okay, the concept. It's in the gravity video and it's in the charge video. I mean, the two of them are related, but you have to understand what absorption is, and, it's just a fact that, to be fair, okay, you have to do that little extra work. So, I shall erase. Explain a change in. Okay, I better pause because, frankly, it's going to take me a second to erase because the eraser is not in the mood to erase. You have to wait till everything's in the mood. It should be back. See if it's working. Yeah, it's only 18 minutes already. See, that's, it's a problem, but I can't do much about it. Turn up the speed on the video. I mean, I will put this on YouTube as a courtesy to Franklin, so he can watch it there. The board's a little too wet. Yeah. Shit. Okay, almost. All right. So the argument is that you have to, these aren't baseballs. Okay, they're electrons and protons. This is the atomic universe. So the forces don't act like, you don't bang something into it. Like a little ball hits it, the ball stops, okay, and this thing goes. That kind of mechanics isn't how this elemental universe works, okay, because the force never stops. So it's like the Descartes vision. He saw the universe as the stuff just keeps going. There's an element to the universe that just doesn't stop, and it just transfers from one thing to another thing. So the idea is that the force, okay, when it's the opposite bit, all right, well, since we did opposite, we'll just have, if a red hits, it doesn't do anything. in terms of giving the blue thing any momentum. What it does is it has an interaction inside, let's say, of some type, square peg, round hole, who cares, and it ends up leaving, right hand rule, okay, it leaves, and it changes color. So when it leaves, it's now a blue bit, all right? That's what happens. So it's like as if it hits a blue bit that's inside, and the blue bit's going, you know, so it's hitting perpendicular. The perpendicular motion means an exchange, okay? So now this has a red bit trapped in it going this way, and now it has the blue bit got released that way. It doesn't really matter how you do all of that mechanically. So the point is that, all right, so now all the red things that come in, you can see, turn to blue. And all the blue things do is when a blue thing hits, it sticks. Okay, so this is going the speed of light, this force. It sticks to the object. It's still trying to go the speed of light. Now it can't go the speed of light. It has to go less than the speed of light because it's a big heavy electron. So it's some percentage. So for each bit that it might hit, like say if there was two of them in a row and they both stuck, you know, so it would be 10% of the speed of light for this one, and then now it's 20% because it's the second one, or a third one, 30%. So the electron can go faster and faster depending on how many have stuck from a particular direction. And they're all coming from different directions, and it just adds up, right? You add up this vector. So one hits from this direction, so you calculate what this vector would be to that vector. And also in that calculation is the simple train wreck argument of, well, what happens when a bit hits from this side and this side? Or it's already moving this way. So it's moving, this bit has a bit stuck to it this way, moving this way. A bit hits this way, what happens? Well, this one's going to reflect, and this one's going to reflect. And that will be like the universe just letting this one go straight through and this one go straight through. So that would be like a non-event. And that's only going to happen though when it's already moving. If it's not already moving in the opposite direction, not moving against it, and it's moving with it, then they'll stick. So they stick when you move with it. They reflect when you're moving against it. So you could add, okay, that's rule 2.5. Okay, so there's not just 2 rules, there's 2.5 rules. Okay, to really understand. So the whole point is this is what explains gravity. Because you can understand that a force would be going a certain distance at the speed of light. Now if I make it push something, then it doesn't go that distance. And that's the difference. This is what's creating gravity. The distance between where the force would have been if it didn't push and where it ends up before it's finally reflected. That is, before it hits a counter force that reflects. And this reflects. So until the two objects, until there's a force going this way, and then as Newton would say, a counter force going this way, until that event happens, this event moves the electron. And it moves until it hits a counter force. Then that one reflects and that one reflects. But as logically you can understand, you can pile up extra force from one side, and then you'll have plenty of energy to plow through the drag you're going to move into. But this is the differential. This is gravity. Gravity is the differential between where the force would have been if it didn't push matter and where it is because it pushed matter. So every time matter's pushed, the field of force gets a little weaker because everything's slowed down. Everything didn't get where it was supposed to be. It's behind schedule now. That's the less energy. All right, now, so I didn't want to really, that wasn't the point here, was to prove the gravity point, but I'm just showing how built into the charge explanation is an explanation for gravity. So you can understand that this is radiating blue, because every red thing that goes in comes out blue, right? And every blue thing that goes in eventually, it can get absorbed for a little while, but it's eventually coming out as blue. So everything blue is radiating blue, and everything red is radiating red. And now you can get the idea of why the red things reflect off the red things, the blue things reflect off the blue things, and the inverse attraction exists because this will never affect this with momentum. Everything that comes off of this will be red, right? Every single ray that comes off of this thing is going to be red. Every single one of them will go some other direction. And it'll end up being blue, right? And you'll always end up with an equal amount of red and blue in the universe because there's an equal number of protons and electrons in the universe, right? The atom demonstrates that. The nucleus has, the neutrons are really electrons and protons. So it's an even number of electrons and protons for the neutrons. Then the protons are obviously the positive elements, and the electrons on the outside are the negative elements, and there's an equal number of those. So that's why you have the same number of protons and electrons in the universe, as you have to understand that the neutrons are also an equal number of protons and electrons make all the neutrons. All right, that should be enough. Oh, it's black and white. I should have thought of that. Shit. I should have taken the color. I should have taken the black and white off. That was, yeah. Oh well. Nobody's perfect. Shit. Is that a theory I have to prove too? Ugh, shit.
But if, like, you have another red charge here, and this red bit hits the red matter, it causes a reflection, and that reflection is actually a collision, and that causes the red particle to be pushed in the opposite direction.
So it's not a Newtonian collision. It's not a bouncing collision explicitly, and it's certainly not an inelastic collision in the sense that it's not deformation and all that crap. It's literally sticking. It's literally retaining its identity. It's pushing the electron, and as soon as a counterforce hits, it reflects and the counterforce reflects. So when an electron's moving through space, everything it's hitting from this direction isn't being delayed because it's instantly reflecting. But everything that hits from this direction is being delayed because it doesn't reflect until the counterforce shows up to cause the reflection.
They can see that as long as it keeps on getting hit by the red bits, it's going to get further pushed away. And I think the simulation was such that if a blue bit like hits the red thing, that not only does it get absorbed, but it also seems impelled towards the opposite direction.
No, so that doesn't happen. When the opposite color hits, it goes straight in, turns, and changes color. It's that simple. It just changes color, essentially. The turn is important because the right-hand rule is important. That explains the perpendicular force phenomenon. That's why electrons appear to be radiating a force as they're moving, is because they are shooting a force that's the opposite polarity to the force they're plowing into as they move forward. As I move forward, the only force that's going to stop me is, say if I'm blue, the only force that's going to stop me is blue force. But a bunch of red force is going into me and it's coming out my sides as blue. So you can kind of get the idea that as I go faster and faster, I start funneling blue force out my sides. That doesn't affect my momentum. I mean red force, sorry. It's blue force because I'm going to change its color. But the idea is it comes in red, it's going to leave blue. And there's going to be a lot of it if I'm moving fast, because I'm moving into a lot of force if I'm moving fast.
But that just seems to be the way the simulation works. Now, so the purpose for Draftscience is to get, confirmation of, this picture, whether this is right or wrong. And so that is what is the purpose of my reply here. And I would say that the main problem with this is that you've simply replaced one mystery, which is, why do positive charges attract negative charges, with an even equivalently harder problem, which is, what are the blue bits, what are the red bits?
Right. So that's, to me, this is I'm not going to, I don't want to be insulting, but this is almost a silly argument. This is the going all the way down, garbage. Oh, if you don't explain abiogenesis, you can't explain evolution. You can't talk about evolution. You can't do anything until you explain how the first DNA molecule was created or some other kind of bullshit. No, it doesn't have anything to do with it. All I have to do is create a mechanism that creates Maxwell's drawings. And I've successfully gotten to a plateau in the mountain. Now, you want to say you want more creationism type details. You want to know what the elemental universe, how it was actually made. So how nothing turned into something, or how something always existed, or whatever that is. I don't do creation theory, all right? I do physics. And physics is never going to give you those answers because we're so tiny, an element of the universe, we're never going to have a perspective where we can start creating universes and see how they evolve. That ain't ever going to happen. And all the stuff that conventional physics makes up about big bangs and all this crap they're obviously just making it up. I mean, they have these silly ideas that there's expansion and space fills, a bunch of space fills in and everything moves faster than the speed of light, but it's not really moving because it's space that's just getting bigger. I mean, really silly explanations. So I don't do creationism. And I don't think I have any obligation to do it. I'm telling you the universe is really dirt simple. Okay, they're telling you there's bent space, and then there's this whole quantum mechanics thing, and then there's this whole idiotic kinetic energy thing. I'm saying none of that shit is true. It's all bullshit, and it's really just this simple mechanism. There's force bits moving the speed of light, and there's matter that doesn't move any speed until a force pushes it. That is radically different, and it's rather complete as a model. I don't need to give you to show you how the key works. You know, I don't have to explain why notches make other things lift up higher and lower and all that kind of stuff. I'm explaining why the key works. That's my job. I'm showing you a mechanical mechanism that will explain why there's gravity and why there's charge and why there's magnetism and why there's photons. I don't need to explain why those simple rules exist. They exist because that's the way the universe is, frankly. And even if I could find the answer is going to be so fucking stupid. I mean, in the sense it's going to be so simple. It's going to be useless. It's not going to tell you anything, okay? It's just the way the universe works.
And why is it that, what is it about the physicality of the red bit such that when it gets the red part, the red matter, such that when it gets hit by the red bit, it causes a reflection?
Right. I can come up with a million explanations for literally. I could just spend all day just giving you round peg, square hole explanations. Well, it's because the red bits are really triangular and, you know, the blue bits are circles, you know, spheres, and the two of them filter for those two different shapes. I could literally do this. I could give you my, the 2 dimensions of the universe are out of alignment. So the red bits are all on these lines, right? All the odd lines, and the blue bits are only on the even lines in all three dimensions. And so they never interact except when there's a piece of matter, because the matter makes it possible for the red bit to hit the edge, and the blue bit hits the center. I can give you a whole bunch of made-up explanations for how exactly the square peg and round hole thing is happening. But I'm just saying, I don't know. It won't make anybody else. It won't make anybody on this planet any smarter to know those details. Frankly, it won't be of any use, because the real use of the theory is you have 2 plus 2 plus 2 in terms of 6 simple ideas that explain all of the mechanisms. And if you want to know why something happens, it's going to be one of those reasons. So every little force bit can be followed, every little matter bit can be followed in the model with just those 6 points of view.
And how does it know that it got hit by the red bit? How does it know it got hit by the blue bit? You just pushed the question about how these things attract.
So again, it's just silly to say it just pushes. Oh, it doesn't answer any of the questions. It's totally useless. It does, well, no, we still have 600 million. No, sorry. I'm just going to call bullshit. It's more of an answer than any other human being has ever uttered in terms of a mechanical explanation that's just too simple. It's straight line, line this way, line this way. I mean, the mechanical parts are so simple. Round wheels, square block of wood, you can't miss how it functions. So, these details, this request that, without the details of exactly how round the round peg is and how square the square hole is, the whole thing is useless. Bullshit.
Can repel to another level. And the other problem is, well, how would we prove this with a physical experiment?
So I would argue all the experiments that matter have already been done, in the sense that the basic experiments. And all they've done is do a lot of them badly. So they did the 2-slit very badly. Because the fact is 2 waves don't work. The math doesn't work. If they actually measure it, it doesn't work. I'd say they did the kinematic experiments really badly, right? I mean, just bang things into other stuff. Well, they have done them so poorly that they think there's free energy, right? I mean, I showed Professor Lewin doing silly experiments where he's making extra momentum. So, I mean, but, when you think about all the different kinds of experiments that have already been done, we have a ton of experiments. That's not the problem. The problem is having an explanation that explains the experiments. My argument to you will be is that this explanation already fits Maxwell's explicit drawings. So it already covers a huge number of the bases. So all the experimental results that exist are confirmation of this theory, in my opinion. And clearly, I would argue, especially the photonic ones, where I've been arguing all this time that photons are in fact rays, and they're just rays of force at a frequency. Well, if you watch the simulation, you'll see rays of force flying out of the material objects at a frequency. So, I mean, it's already doing that.
Yeah, science is about having a hypothesis. This is a hypothesis. I think it's a legitimate hypothesis, and I think that there actually has a lot that is right about it. I mean, I think actually this is, in a way, actually is totally right.
So that's, ironic in terms of what you just said, which was it doesn't answer the vital question. It just pushes the question off. It just shoves pushes the big questions under the rug or something. So, those are kind of contradictory statements. I appreciate this statement, and the acknowledgement that, at minimum, it's damn interesting. I mean, it can't be something other than an interesting theory in terms of it's such a simple answer and it does fit. Now let's see if we can find something elemental that's broken.
But it still has to be testable, right? So unless you have...
It's only testable, again, with our instrumentality. You're never going to see a photon, okay? Because we just can't physically interact with one with any kind of energy that we can not destroy the photon by trying to look at it. So we already know we're going to have those limitations. And so all we can do with models is simulate and have the model show you how it produces the outcome. And as long as the model isn't doing something wooey, like, well, then the magic wand pops out and goes poof. Well, yeah, that's a broken simulation. I'm telling you, just because I've engineered this simulation, I know what it's doing, okay? And it's just doing these simple rules. It's just obeying these two simple rules, essentially. That's all it's doing. And I'm just saying it's quite obviously quite impressive in the sense that it's already forming atoms that are already absorbing energy and spewing it out in different patterns. I mean, come on.
Any way of identifying what these force bits are? I mean, is there an experiment that you can devise that can tell me that...
Again, you won't see gravity. You're not going to see light. You're not going to see magnetism. They're all made of this stuff that is so small that we can't take a picture of it. So all you can know it from is its symptoms. You can just know it by its effects. You can just model its movement. You can't photograph its movement. No one will ever photograph its movement. So I could tell you that a photodetector is picking up the energy and it's pushing an electron. It's doing all of these things that would be perfectly consistent with this theory. So I'm just saying that's all I can do. And that's all anybody can do. And what I'm arguing to is the conventional theory clearly has huge gaps in the connections. The connections aren't connected. Richard Feynman overtly says they shouldn't be teaching wave theory, yet he believes in a probability god.
These force bits exist? Or can I make a stream of these things? Can I make a particle beam of just...
So I'm surprised you didn't see that in the simulation, because it does it all the time. I mean, you just watch it and you'll see the stuff shooting out all the time.
Like red force bits, and then compare them against a beam of the blue bits. So generally speaking,
see, the blue bits don't have any power. If we're going to say the blue bits were protons, it's probably the other way around, right? Red should be positive, but they don't have any power because all of the protons are locked in the nucleus, and this might just be because of the way the universe forms atoms, pushes them into their original configuration and locks them together essentially with all this pressure built in. But it's probably more likely that there's, a slight, modification to the simple rule is that protons move slower than electrons. Because they move slower, they're stuck on the inside.
Don't think so. But like I said, I think that this is a great idea. I think it's actually correct, but it doesn't quite get all the...
I know. So, yeah, okay, I get this sort of, but I don't know. It's correct, but it's not correct. Or it's right, but it's not right. So you could just say, I think it's a very interesting idea, and that would be good enough for me. Okay, I'd be satisfied that you find it intriguing. So, yeah, good enough for me. Okay, and now we can have arguments about how it fits or doesn't fit. Because I have been over those. I've been over this and over this. I mean, I've spent years on it, so, I can challenge the drag arguments, and I can challenge all these different arguments with an explanation.
Way down to something which is not yet another mystery. In order to get this down to something which is not another mystery, you would have to get it down to just plain Newtonian mechanics. So the only thing that we have in Newtonian mechanics...
So this is where I stopped previously listening. And then I decided to make the video because I said, fuck taking notes, because this is just way too complicated. So this idea of whatever Newtonian mechanics is, as I kind of said earlier, the only universe that's real is the smallest universe. Okay, the electrons, protons, and their energy. And what we see rise out of that, those laws aren't the laws for atoms, and they aren't the laws for electrons and protons. So because baseballs work a certain way on Earth, in atmosphere, on all blah, 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 doesn't mean that's how the elemental bits operate. So the idea, and I'm not asking you to stretch very far from those rules, in the sense I'm just saying, to understand elastic collisions, you have to understand that it actually sticks. It doesn't deform, it doesn't change, it just sticks until a force from the other direction hits, and then it reflects. And that's it. They both reflect. So it's a Newton's cradle. I can use Newton's cradle, but you just have to have a slight modification to Newton's cradle and understand they actually literally stick.
Is that we know that when one bit hits another bit, there's going to be a collision, there will be an exchange of momentum, and then both bits will fly away from each other. So this bit about,
So that's not even true what you just said, right? So if an electron is sitting here and I hit it with the force bit, by Newtonian mechanics, the force bit should stop moving, just drop dead, and the matter bit should move. That's Newton's mechanics. And the argument is no, that's not really how it happens. The force actually pushes electrons and protons wherever they go. So they never have momentum of their own. They don't fly through space like a wrench. You don't just shoot, you just don't throw a proton and have it keep going. It's in a constant field of energy that will absorb its motion. It is literally dragged to a halt by the fact that it's running into more energy. So that game is over. The only thing that can overcome that is when you put a few electrons and protons together in a helium nucleus, then you can overcome the drag, because it absorbs and releases pressure as it hits the drag. So it overcomes the drag by storing energy when there's no drag, and then using it to get past the drag. But that's a whole subject in itself. I could spend a whole, couple of hours lecturing on the mechanics of potential drag. But I'm just saying the Newtonian notion isn't a strict notion. Electrons and protons aren't baseballs and golf balls and bowling balls. They're not asteroids. They don't break in pieces. Lots of things don't happen in that universe. And the argument is they're all indestructible. Electrons are indestructible, protons are indestructible, and the force bits are indestructible. And the only way a piece of matter has momentum or movement, it's because there's a bunch of force actively pushing it. It can't have movement unless it has the little flagellums. It had to capture the fish to make it go. It can't go if it doesn't capture the force. So anything moving had to capture force to move. Now, of course, all motion is relative and blah, blah, blah. We don't know whether the Earth is going this way and I'm going that way and all that other crap. But I'm just saying the movement, when two things are moving relative to each other, something has the real force in it. Something has actual more fish. that are making it move.
Positive bits hitting each other, causing this bit to fly away. That's Newtonian mechanics. That's perfectly fine. The only problem is we can't explain why is it that when the blue bit does the same thing, that it doesn't do the same thing, because it should do the same thing, right?
No, there's no it should do the same thing, because as I pointed out, they're obviously different things, right? They're different colors, square, round. It doesn't matter. Blue and red is just a metaphor for there's a difference. And the difference, the electron knows the difference and the proton knows the difference. I mean, I could say penis and vagina. I could say lots of things. Okay, I could use this as actual mechanisms, okay, that make it possible to know the difference. But they're physically different. Yeah, I don't have the telescope to see down there, the microscope.
Any particles hitting any other particles should cause an elastic reflective collision. There wouldn't be two interactions, there'd only be one, and that would be the reflection reaction that pushes everything away.
Yeah, whatever. I can just say to you, well, no, it's not true if you just give the electron and the proton a small amount of mechanism. Square holes and round holes, well, there's no point. I'm just saying you want a detail, another detail. I'm saying I've done my job. I've duplicated Maxwell's theory. And to me, that's more than enough of an accomplishment.
And in Newtonian physics, that's generally all we have. That there is problem is that there's no, say, attractive interaction in Newtonian mechanics. You've got two billiard balls. The only thing you can do is hit them against each other, and all that's ever going to...
Look, it's a push universe, so that's another one of my theories. I mean, I don't really need to make a push simulation, right? Because the whole simulation is push. There's no other event that takes place in my theory than pushes. And all a pull is the absence of push. So when you have the red thing next to the blue thing, there's no push because all the pushes are deflected. So there is no pushes. So therefore there's pushes on the outside, no pushes on the inside. The two things move into each other, kind of obviously. So it's a pretty simple mechanism. It's pretty consistent with a fundamental rule that it's really easy to manufacture a system that can create push. Just throw something, push. Very difficult to ever conceive of something that's an actual pull. If I pull on a door, I'm pushing on the back of the doorknob, right? I mean, you can always find the pull is really a push. There is no pull. Pulling on a rope, you're pushing on the rope, okay? You're physically grabbing it and pushing it that way. You're not pulling on anything. You're pushing the rope that way.
Do is cause them to fly apart. The only way you can get two billiard balls to roll towards each other is if you hit two billiard balls from the opposite sides, and then they will roll towards each other. But what generally happens is that there's really only a pushing force that's available.
Right, and that's exactly what my theory is, an entirely pushing force, right? I mean, I couldn't make it any clearer, right? The universe is a closed vessel, so to speak, and there's a bunch of stuff moving around in it. What is it doing? It's pushing on the vessel. It's pushing on every single piece of matter in the vessel. It bangs into it, imposes momentum. And the only catch is, right, is this little color deflection thing. No big deal, because it perfectly explains charge. I mean, it's a tiny little use of your imagination to extend the function that one little bit to say square peg, round peg. And understand there's a little distinction between the square pegs and the round pegs. Well, that's not too much to ask from your brain's imagination, is it? That there isn't one kind of peg, there's two kinds of pegs, two kinds of holes. Is that really asking so much from you?
So like I said, my general conclusion is that I think what Draftscience has here is actually what is going on, and that there really are two force bits. There really are two kinds of matter, and there really are two types of interactions. But the question is, how do you make this actually work in...
So I see where Franklin's going now that I read the comment, right? Because he's going to start talking about the C's. Because he thinks the force needs some way to move from one place to another. So it needs a soup to move through. It needs a medium to move through. And, I understand, okay, you can be that way, that the dominoes need to hit other dominoes and flip through a series of dominoes. But I'd still argue that it's just as simple to flick the domino, have it fly someplace and land. Dominoes can get through space just fine. They don't need a medium. and the medium just creates a mess where now you have all kinds of possible distortions and this doesn't help, in my opinion.
Say the known physics world. So I'm going to try and present how I think that works. Okay. So this is my proposal. So, like I said, I'm not really contradicting anything that draft physics has to say about this picture.
And let me be honest, I get what you're saying, okay? I get that we could just turn this into what is the thing happening on the inside of an electron isn't necessarily the same as what's happening between them. In the sense you can create a different medium that just carries the information of it got bigger, it got smaller. An electron moved this way or that way. Yeah, you jerked into the dominoes fell, they're going to hit the other thing. So you're putting a medium in. I'm just saying that we should agree to the fact that maybe, I'll concede that, it's okay with me, so to speak, if you want to put a medium in to carry the force, for the force to travel through. But I would argue that you should also make the same concession to me that, yeah, it's just as easy to do without it. So just like Einstein said, about ether, it's superfluous. It doesn't enhance the function any, because you still have to explain the real source of the energy. The thing that knocks the first domino, the first cause is what you're really looking for, right? And it's a system of energy constantly moving through the universe, so the first cause is always going to be, that bastard did it. And that bastard's going to say, no, that bastard hit me first. So, it's always going to be that the energy is in the field. We all have to start with a movie that's already in motion. The universe is already in motion. It can't start from standstill and then go. It's already going. So if you have an ether, you would have to concede your ether has a ton of energy in it. There's all kinds of stuff moving through the ether. So the ether's really moving. It's not a static thing. It's not jello. It's stuff going all over the place all the time. So isn't that the same thing as me just saying, well, let's just do without the ether and just throw the dominoes?
Sure. I'm just going to try to explain what exactly these things really are, okay? Now, so I'm going to explain that in my hypothesis, that we do have these little bits that fly around everywhere, okay? That's true. And the question is, another distinction between me and him might be is, well, let's describe their size. In my simulation, there's 5 or 10,000 of these things in that bubble at any one moment, right? So the percentage of the surface area of the electron and proton to the number of force bits, it's going to be some huge ratio, all right? The density of the force is gigantic. If one of the force bits was made out of just little force bits, it would be made out of tens of thousands of them or millions of them. That's the density. What are these little bits, okay? Now, it actually doesn't matter what these little bits are, other than they do act like, grains of sand or flying everywhere, or like gas molecules. It doesn't necessarily matter what they are. If you ask me personally, I would say they're like neutrons. So like the entirety of space is just filled with these.
See, that's where we just disconnect so much, because to me, neutrons are gigantic. They're freaking huge. How could neutrons be having anything to do with this? They're gigantic. You can't miss a neutron. It's going to deflect all kinds of force all over. It's gigantic. It's an electron and a proton. It's huge. There's no way that the medium is neutrons, because then the resolution would be horrible. The grain of the universe, the Planck constant would be 15. It'd be a big giant number, not 1 times 10 to the minus 700. It would be a giant number.
Neutral particles, but for the purposes of this explanation, the actual composition doesn't matter. So what are these bits? They're basically neutrons. Okay, now the question is, what are the force bits and what makes them different, right? Okay, so you cannot distinguish any one neutron from any other neutron. But what you can do is that if you have this sea of neutrons, then you can create waves in those neutrons, right? Just like sound waves. And
gigantic waves. I mean, they'd be humongous waves if you're making them out of neutrons. They would be so frickin' gigantic. How could they hit little discrete elements of matter? I mean, how could they affect electrons and protons in this individual way? No. Can't be.
So what I'm thinking is that in the quantized world of space, we're going to have the only difference that you can have in a sound wave is actually the phase, right? So I'm going to say that what's really happening is that we have, the blue matter bits, and we have the red matter bits. Okay, so this is what I'm going to say is happening. You have the blue matter bits; they're outputting a wave in a certain phase. So let's say that we have a phase that goes down and then up. Okay, and then we have the red matter, and that it is putting out a wave, but it's in the opposite phase. So when this thing is going down, this thing is going up.
All right, so this whole up and down thing doesn't really say anything. So, I mean, obviously, I think I would want to convert that into there is bits, there isn't bits. So the up part is there's a whole bunch of bits heading for me. The down part is no bits. So I'm not getting hit by anything. So I'm getting hit from stuff behind me, I move forward. When a bunch of stuff hits me, I move backwards. Right? And every time I move, I'm now reflecting the universe differently also. So every time I move my hand, again, I've used this argument millions of times, but theoretically, if I could move my hand at the speed of light, it would collect every single photon, would get stuck right here, because my hand's moving the same speed as the reflections. So none of the reflections can gain any ground on me. My hand is going to collect every single reflection, and when I show up at your house, right, my hand is going to blow your head right off. And the inverse happens. I go backwards at the speed of light, I disappear. I don't exist anymore.
And this is continuous. So this is what I would say is differentiating the blue from the red. That instead of being an actual particle or a bit, you can think of this as a wavefront. And
so I can't do any of that, frankly. I can't. This whole rays of waves, ray waves. No, just waves spread. This is the Feynman argument. Waves spread. Photomultipliers aren't picking up the spreading wave. They're picking up a tiny little discrete spot.
This red thing is like when it's say pointing out of the screen, and but the blue one thing is putting out waves, and so that's pointing inward to the screen, right? So
yeah, well, I haven't bothered with the three-dimensional thing yet, just because that's going to get a level of complexity, because obviously a right turn, in 3 dimensions, a right turn is either this way or up, right? So you have a right turn is anything in that section of the 3 dimensions, theoretically, because you can't. That's only you can't orient any other way. So you have 2 options for right turn, and the options are 2 of the dimensions are on the same plane, right? This way and this way are on the same plane, and it's this way that's off the plane. So no matter which way you turn the universe, 2 dimensions are on the same plane, and 1 dimension is the opposite one, right? So there's action happen on the 2 planes, and that action is converted into action into the 3rd dimension, which is almost a separate dimension, right? Because this 3rd dimension can put action back in and cause action left and right. So that's the interesting part. But the honest answer I'd give is that 2 dimensions are enough to illustrate the mechanics.
What happens is that we know that
when you get into the geometry of the atoms, that's when you're going to need the 3 dimensions, because obviously it's a huge advantage to have the other side of the pyramid, right? If you're making a pyramid and it has the extra sides are going to be really important to the geometry.
And waves,
I mean, a cube is a lot more than a square.
Of opposite phases come together, they cancel each other, right? So
I'd argue there's no canceling anywhere. There's no such thing as an energy ever undoing other energy. All they can do ever is reflect. The energy never stops. Descartes was right. You can't kill the energy. You can't kill the matter. you can't make matter, you can't make energy. It's a closed system. It has so much action in it, and the action is just revving up over here and slowing down over there, and that's all there is. It's hotter over here, it's colder over here, it's colder over here, it's hotter over here. It's never going to change.
But when the waves of similar phase come together, they add together, right? So this is what I am proposing to separate out what the red and the blue bits are. Is that they're not bits, but I can think of them as waves.
All right, see, I just can't even come close to being able to say I understand how you can do that. I agree, they're bits, but they're not bits, they're waves. I just can't, can't do it. Can't make any sense to me. I'll try, but the whole point is the fact that you're creating this spherical symmetry, and again, Maxwell's drawings are using rays because, rays work really good. It's a really good way to understand what's happening and how to calculate how much stuff is hitting you by understanding as the rays go out further and further, they're separating from each other in 2 dimensions. That's the inverse square law. They're going away from each other this way and this way. The 2 planes of the dimensions that are on the same plane are expanding in 2 directions. That's why the rays hit you less and less frequently as you go further and further away, is because they're getting further and further apart.
They're waves that are coming out. They're waves that are coming out from, say, the blue object. Let's just call that, say, negative. And then we have the same waves which are coming out from the red object. Let's call that positive, okay? So what happens is that physically...
So you're agreeing with the concept that this really does solve the problem of understanding that if they are interpreting each other and converting each other equally, that you'll end up with this effect where you have them radiating an opposite effect. And so, yes, so that principle you're agreeing with, and you're just converting the particle model into a wave model. And again, I would say that I can make lots of arguments why particles work so much better, because all the forces appear to travel in very straight lines. Very straight lines. Straight lines.
Is that when the red wave hits the blue object, it's going to be out of phase, and therefore it's going to cancel. So that when they come together, there's not going to be any net force. But when there's another thing where the waves can't hit the waves. In your theory maybe that's possible. In my theory that's not possible. And it's sort of proven with gravitational models and even charge models that you have to wait for the field of energy, the rays of light, to actually get to the material substance. The rays of light can't intersect each other in mid-space. They have to get to the object. So this is one of those things, again, where I'd say there's lots of experiments that sort of demonstrate that's the truth. You can't bang a laser into a laser. You can't make these things interact with each other in the field. They have to get to the matter for the interaction to take place. The interaction that matters to the force is the interaction that changes the force by interacting with the matter. The
force can't interact with force, and matter technically can't interact with matter. The force changes the matter. The matter, by moving, changes the force.
But when the wave from the red wave, similar wave, hits this thing here, then all of a sudden we have 2 waves pushing at the same time at each other. Right? It's similar to, like, if I had my hands and things were in phase, I went like this, then they would never hit each other.
Right. So this idea that they always know what phase to be in would be kind of an argument, like you're saying now, that electrons are always vibrating at exactly the same frequency and phase, all the electrons, and all the protons are out of phase with those electrons. So they're all in the opposite phase. But that's the same thing as me giving you the separate dimension argument. Just saying the 2 things are on separate lines in the 3 dimensions, and only red force goes here and the blue force goes here, And I could just say they're just out of alignment with each other. And they have to get to the matter for that in alignment to be turned into an interaction. For them to interact with each other, they have to hit the matter, because the matter is where the strings cross each other. The strings that the beads are shooting on, the red beads are shooting on, get crossed inside the matter, so now the blue ones can hit the red ones. I mean, I can make up lots of stories. I just don't see the necessity of it. And I don't think it gets to the fundamental point that what charge is easily described as this mechanism of a simple square hole, round peg argument.
Each other. No force would ever be exerted. But when you have in phase, then it hits each other, right? When you hit each other, then we have Newtonian force pushing the other thing away, right? You can always push it, but I'm going to go like this. Nothing's ever gonna,
So again, there's no push, and you go with it kind of thing, unless you're making an argument about sticking. And then if you're sticking, you're pushing something slower than you're moving. So again, all of that has to be made clear that Newton didn't say, you can throw, that was actually Leibniz kind of theory, that you could take a pea and hit a boulder and both of them would go off at the same speed. That was the kind of crap Leibniz thought might be possible. Right? The inventor of mv squared. Newton didn't think any of that kind of crap. I mean, he knew that there's only one ball of the energy, the force, and that what's happening is that the force in this is lost and given to this. You can't have both. You can't have this go 50 miles an hour, hit something, and they both go off at 50 miles an hour. Can't happen.
Out of phase. They're never going to push. Okay. So this is how you get the two interactions that he has. That you either have the in phase interaction, which is a push, which is going to be a Newtonian push, because ultimately there are going to be particles that are going to be smashing against each other, and they are going to push against each other, and that breaks down what actually causes the force down to only a Newtonian force, right? There's no necessarily an absorption force, an attractive force necessary to explain this interaction here.
I guess I would just argue this equilibrium argument is the one that takes care, it takes all of this and focuses it. So you can understand that everything can't make energy. So even the sun can't make energy, right? It can only store it from someplace else and then release it. But there's no such thing as just making it, right? And so we know that every object that doesn't have an engine in it to make energy, we're pretty sure the Earth isn't burning any oil, right, to make gravity. The Earth isn't using a fuel to make gravity. So the idea is pretty obvious that the fuel has to be coming from the outside. And the Earth is consuming the fuel of the energy coming from the outside. And obviously that would mean it can only produce less than went in, because it consumed a little bit of it to make the gravity, to move the electrons and protons, to heat the Earth.
So just Newtonian. So we've taken it from another mystery, which is like, what are these blue bits, what are these force interactions, and broken it down to waves.
Which don't explain anything. I'm sorry, they really doesn't. To sit there and say there's these preposterously huge waves moving through a field of neutrons, you're saying that doesn't open the door to a million questions? Of course. I mean, what? They're neutrons. How do they even stick to each other? What? How do they carry this wave? How do they convey the wave to each other? What is the neutron made out of? If you believe it's an electron and proton, well, are the electrons and protons going this way? Or are they going this way horizontally? Which way are they going? And how can the energy going this way, hitting an electron and proton that are oriented this way, how could that energy move forward? That can't happen. So they have to be going this way, and the electron moves closer to the proton, and that causes a blah, 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 blah. I could ask you 5 million questions about what's the square peg and round hole of your wave theory. So I think you'd be a little unfair to say somebody else is incomplete. What you have on that little tiny board is also a little bit incomplete. But thank you for drawing it. Appreciate it.
Is just Newtonian. And this kind of interaction, actually people 100 years ago have experimented with this kind of phase relationship. and they had like two pulsing balloons and found that, yes, indeed, if you had two pulsing balloons, if they're pulsing in phase, they will repel each other. If they're out of phase, they will in fact attract each other.
Yeah, but that's it's like almost obvious. You're creating energy. Now, the attracting part, I'm going to say no way. But whatever. You can show me that. You can show me where the two vibrating balloons could possibly ever attract. But if you want to get into that whole the new kind of crap, the swirling water crap, I can give you lots of arguments why that crap can't be what the universe runs on. Because you need about 1,000,000 watts of energy to make 1 milliwatt of attraction. And obviously that's not how magnets are working. There's no, 1.7 gigawatts or whatever the funny line is.
Because the particles in the surrounding, that they had it immersed in a water tank, all the little particles of water do actually act to push or pull these pulsing objects apart, right?
Right, at an incredible price in fuel. So to get a tiniest bit of attraction or the tiniest bit of a propulsion, you have to put in 1,000,000 times more energy than the actual energy of the movement you're getting out. So the proportions are awful. The squandering of the energy is insane. So it makes no sense.
So to conclude, I would say that, yes, draft physics has shown a very interesting concept here.
That's it. Bingo, good, thank you. Should have just made a video where you said, very interesting concept, thank you. I'm still busy doing my neutron C thing, so yeah, I'm too busy doing that to care too much, but okay, interesting. Something like that.
It's still not getting to the root.
Yeah, please, it's just too silly. I'm sorry, it's just too fucking silly. Compared to point me, you'll go and point me to your own theory. But, let's say your theory doesn't exist. Point me to the alternative theory presented by anyone that has more functionality and fewer details. In the sense that it doesn't need any more details. Something simpler that says more. Show me it. Somewhere else. I know that doesn't exist, frankly.
Physical root of why, say, an electron should attract a positron. And so what I have done...
Yeah, well, positrons are just baby talk from my perspective. Where's the negatrons? How come there's no negatrons? What happened to all the negatrons? Where have all the negatrons gone? Where are they hiding?
Is that I...
All right, I pause for a moment and such. All right, back. An hour and 12 minutes. Sorry. Maybe you can play it really, really fast and almost hear me.
Taken this idea and explain what each of these things could possibly be down to the Newtonian level.
So again, I just dispute that whole nonsense that down to Newtonian level. I've already explained their bits. I've explained exactly how they function in the sense that they're going the speed of light. They don't go the speed of light when they're pushing the matter. Now, what exact number it is, how exactly heavy an electron is. I don't agree that they actually have ever measured the electron correctly because they're using this stupid kinetic energy formula to measure the mass of an electron. So they don't know how much an electron weighs because they have the wrong formula. But regardless, it's heavy to some extent, and the proton's heavier to some extent. And so their speed is what it is, okay, in the sense that it's some number. Now, eventually the simulation will show us what the number is because it'll work better at some speed than it works at some other speed or something like that. But again, these details are, whatever. I'm sorry, I'm not that interested. And I developed the formulas and they developed the whole thing, and I'm just not even that curious. To me, the outstanding feature is understanding the material universe is a material universe, and that the force and the matter are the only two players, and that the force is doing all the acting, the moving, and the matter is doing all the victimized, just being a victim of what the force says.
So they can explain how these things are actually getting the two interactions which are required in Draftscience's 2 + 2 + 2.
Well, let me just give you a clue. It's probably going to be a few million years before... I'm sorry. those answers, I'm just saying, I think those footprints have long washed off the shore, the sand. You're never going to see those footprints again.
Yes. So that's all I have for today. If you have any comments, please leave them below. Thank you.
So anyway, really appreciate it. This has to take place, in my opinion. People do have to argue each other. They have to even maybe insult each other. They have to even hurt each other's feelings a little bit. Anyway, but people do have to interact to explain why they see something as reasonable or unreasonable. I clearly think I have presented enough evidence of a reasonable explanation for the mechanical function of charge, magnetism, electricity, and gravity. And a request for more detail that is hypocritical in the sense that you're not going to demand it from anybody else, I think is sort of bullshit. Okay, so until you can show me a picture of your neutron sea, show me the experiment that indicates that big giant neutrons are bouncing around in this sea somewhere, that neutrons don't make gravity, because they'd have to make gravity. If they were neutrons, that means they're electrons and protons. Electrons and protons, in my opinion, are making gravity, their movement. So you'd have to explain why the neutron sea isn't gravitational. I mean, right there you're in big trouble, in my opinion. But this was excellent. Thank you. I almost want to pay you for it. Appreciate it. Fantastic. So that's enough of a video. Sorry for the length, but I can't, they're all subjects that require some detailed explanation. You just can't explain anything too simply. And physics is one of those subjects that has a lot of nuance to it. Lots of experiments. And you have to put them all in there and say, yes, yes, check all the marks. Oh, yes, I passed that experiment. Yes, I passed that one. Yeah, it passes that one. And then you have to figure out which ones are bullshit. What are experiments where they say something, oh, and that's probably not true. When they talk about electron guns. Electron guns aren't just shooting electrons. They're shooting a whole bunch of atomic pieces. All kinds of ions and all kinds of electromagnetic radiation. That's why they have to put shielding up to protect themselves from the X-rays being created by the electron gun. So, all that stuff gets a little messy. Because they say something doesn't mean that's actually what's happening. So physics is it requires some, you have to spend some time going through all that stuff of why you're certain of something, why you're confident, why you believe it. Oh, I should do this thing. So this has been a draftphysics.com or debatephysics.com video presentation and such. Thank you for your attention.